Hi, my name is Mark Thorsby, and this is Think for Yourself, an introduction to critical thinking. I hope you guys are doing well. If you'd like to follow along, we're using a workbook for arguments by David Morrow and Anthony Weston. So I hope you guys are doing well. If you've been following along, you know that in the last video, we introduced the topic of generalizations in critical thinking and the role in which generalizations play really an important element in the types of arguments that we frequently encounter, as well as the types of arguments we frequently make. One of the things to notice here is that a generalization is always a form of inductive reasoning in which one tries to apply the characteristics of an individual, a member, or a species to the characteristics of an entire category, a whole group, or what we call in logic the genus category. So this is what generalization ultimately is. There's good and there's bad forms of generalizations. As we looked at in our last video, when we make generalizations, we need to make sure that we use more than one example, because if we want our generalization in the argument we give here, where we apply the characteristics of individuals to the whole group, we want to make sure that we use multiple examples. We also want to make sure that our examples are actually representative and relevant. Oops. So that brings me to Rule 8, and this is what we'll be taking a look at today. The notion that when we make generalizations and arguments that employ generalizations, we need to make sure to use representative examples. Okay, so this means that the sample size is not enough. You'll recall in our last video we talked about what a sample is. A sample is the number of examples of individual characteristics you use in order to make a generalized claim about an entire category or group. If you've taken any psychology or any sort of social experimental courses, then you'll actually probably have a much more in-depth understanding of what a sample size means. Keep in mind here that we're just talking about sample sizes really in terms of a very broad and a very general level here. So the important though is that sample size is not enough, right? Just because you have multiple examples for the generalized claim you're making doesn't mean that your examples are fully relevant. For instance, imagine this argument. Someone says, Hillary Clinton is going to win the presidency of the United States because everyone I know in my neighborhood supports her. Well, you can see from the get-go that's not a very good argument. You can see it also stands as a type of generalization here because this person has said, listen, I have a couple examples. Every person I know in my neighborhood is going to vote for Hillary, so therefore Hillary must be the person who's going to win the presidency. But you can also see that's not a very good argument because the presidency involves not just having lots of personal examples of people I know who are going to vote for Hillary, but it needs to be representative of the constituency that she's running for, right? That is Hillary Clinton, how many people are going to vote for Hillary Clinton across the entire country is really the right question here. So you can see here, it's not just about how many examples you have, but that your examples are relevant. And when we say relevant, we mean that they're representative. What does that mean? Go back to our notion here. We said that when we make a generalized claim, we take the characteristics of individuals and apply them to the whole. So that means that the examples that we use, the examples that we give, need to be ones which represent the whole category, not just one, sliver of that category. So the representativeness of the example depends upon the fuller category itself. So we can say here that examples used to support a generalization should not only be sized correctly, but they should also represent the entire category. So there's a sort of critical question here, which is, well, what exactly makes a sample representative? And there's a really helpful term and concept we can use here in order to make sense of this question. And this is the concept of the cross-section. And what we'll say here is that the examples that are given to support a generalized claim should represent a cross-section of the category that gets generalized. Now, in order to explain this, I pulled up a picture here of a cross section of a piece of wood. I just pulled this off online. You can see there's a tree trunk that they've cut in half, and they're showing us the different parts of the tree rings. Notice there's different parts, so we can say that the tree represents the whole, but notice how there are different parts, and there are different proportions of the whole, and the different proportion of the parts within the whole. So for instance, there's the bark, right? There's also the pith, right? There's the sapwood, the annual ring. There's all these different parts and components of a cross section of a piece of wood. So you can say here, one of the things we have to look at is if you want to create a sample that has an appropriate cross section of the entire category, that is, it actually represents, then we have to think about first what the different parts of the larger category are, right? What we can say here is that a sample that represents an adequate cross-section of a category is one in which both A, the components, and B, the proportions of the full category are represented in the generalized examples or in the sample set, okay? So this basically means that, let's imagine I'm making an argument about the types of people that like to watch football on TV, right? So let's make that my big category. And you can ask here, well, what are the different parts and components of people who watch football on TV? For instance, we know that for instance, newscasters watch televised sports on television. It's their job. So that means that when we say the entire category of people that watch football on TV or sports on TV, sportscasters are included. But sportscasters are not very representative of the entire cross-section of the category. Why? Because they're not the only people that watch sports on TV. So not only do we have to identify which people count within the category, what are the components of that category, we have to also understand what the proportion of those components are to the fuller category. And when we can get our heads wrapped around the components and the proportions, then really, and only then, will we be in a good situation to actually create a sample size that's representative and that ultimately should be multiple too. You don't want just one, but we'll have a large enough sample to make our argument. Now, even though clearly sample size here is an important element when you're thinking about experimental psychology, for instance, but for our purposes, in terms of critical thinking, a sample just refers to the sets of examples you give to make a generalized claim. So let's imagine, for instance, you're writing a paper, for instance, on a certain demographic group in a certain city in the United States. Let's say you're looking at Hispanic males in New York City, right, for instance. Well, so if that's going to be your sort of sample, if that's going to be the category you're looking at, and you want to know more about those people, and let's say you're making an argument about them, right? Your sample size needs to include examples of types of persons who are Hispanic, male, and live in New York City, right? Proportionally in terms of relation. So you can look at, for instance, you can make an argument saying that there's a number of different individuals, all who fit the demographic information, and all of whom are underrepresented in Congress or something like this. And you could begin to make arguments this way. So again, sample size doesn't refer necessarily in our class, critical thinking, it doesn't necessarily refer to an experiment. Here we're just talking about the types of reasons that can be given in support of a conclusion. Now, remember, this is all about learning how to make good generalizations and also be able to spot bad generalizations. So in an effort to improve our ability, if you're following along in the book here, there's an exercise set you're going to want to work on. And what we're going to be doing is we're going to practice recognizing sample bias in order to avoid unrepresentative examples. So let's lay down some language here. First off, what is a biased sample? A biased sample is really any sample that fails to represent the group accurately, both in terms of its proportion and in terms of its composition. Now, one of the ways that you can get around bias samples is by random sampling. And what is a random sample? Well, a random sample is one in which every member of a category has an equal chance of being included in the argument, right? So you can imagine if you're actually doing sampling in psychology, right, you want to randomize it. But also think about this way: if you're making a generalized argument about a certain group, what you want to do is ask yourself this question: does my generalized argument hold for any random individual of that category for whom I'm making this claim, right? So for instance, imagine if I make the claim that all American men are tall, right? Let's make that our claim. Well, if I'm going to support that, I need to give examples, right? That's a generalized claim, so there's going to need to be examples to support it. But you could say here, the examples I choose, right? If my sample is representative, it could be also randomized. That is, I could pick any random person in America, random, I guess, American male, and they should support my conclusions. That's what randomization is all about. I think the key things to remember for us is remember proportion, composition, and also relevance. Okay, so take a look at this example. And then let's take a look at what we're going to do is we're going to read this example, and then we're going to see if we can figure out what the sample biases are, if there are any. And this is an example I've taken right from the book. In this case, here's the quote, or here's the problem. Okay, I'll just leave it at that. Derek W. took a job at Schnucks, a grocery store in St. Louis, to help pay his way through college. As his student debt mounted, he took a break from school, planning to go back when his financial situation improved. But with the economy still stagnant for years after the financial crisis, Derek has found that many of the other employees at Schnuck are college graduates themselves, some with degrees from prestigious schools. It seems that a lot of college graduates can't find work that pays any better than the job that Derek already has. So you can see here, the next question here is, well, why should Derek even be concerned about going back to school? Now, this argument, I like this argument because it's a good example of a generalization that you might easily hear in your own life, right? These are the kinds of arguments that we're often confronted with when we hear people give evidence for their claims. Now, the question here, is there sample bias? Well, for the one, number one is, remember our earlier rule was that you have to have more than one example. Well, Derek has more than one example because he's talking about many of the other employees, so he's got multiple examples. But are these examples representative? You can see here we have to compare the premise to the conclusion. The conclusion is this final claim, right? It seems that lots of college graduates can't find work that pays any better than the job Derek already has. So you can see here in the conclusion, we're talking about really the whole category of college graduates, at least at this particular time. But you can see here, what's the evidence, what's the example that he's given, or this person's given. The example they've given is only people who work at Schnucks, a grocery store in St. Louis. The problem here is that college graduates work in many, many more places than Schnucks, right? Just because everyone he knows at Schnucks has a college degree, right, doesn't mean that everyone who has a college degree could only get a job at Schnucks, right? So you can see here that there's a sample bias that's going on. The sample bias is that we're only looking at people from Schnucks, when instead we should probably be looking at people from other places. You can imagine maybe a better way, if we're going to revise this argument, is to look at college graduates in St. Louis, after all, right? And then, or if you're going to talk about all college graduates in America, you could even extend it even larger. Now you can see here that the larger we try to apply the argument, the harder and the more examples we're going to need, right? This is why you have to be careful with generalizations. So when we generalize, you want to generalize really, I think, as conservatively as possible. That is, you want to make as few generalized arguments as possible and as few generalizations as possible. So one other way this argument could be corrected is we could modify the conclusion. We could say it seems that lots of college graduates who work at Schnucks can't find work that pays any better than the job that Derek has. So there's two ways we could fix this. You can either fix the example, you can also fix the conclusion. Okay, that is the exercise set. In the next video, we'll be taking a look at background rates and why they're crucial for thinking about generalizations and evaluating generalized arguments and claims. Thank you very much for watching. I look forward to seeing you guys online. Bye.